Hello everyone, how are you doing? I'm with my partner Jacob Haft and I'm Joe Balone, and today we're going to be going over master cylinders and how they operate.
So we're going to run over the basic operation of the master cylinder. This back here is your input from the brake pedal. Now what's going to happen when you push the brakes is this primary piston is going to move. And as it moves, the primary cup seal is going to move past this port. Once it moves past that port, it'll begin to build pressure in this chamber. This chamber's pressure will be sent out this first port. It's hard to push this, but you can see this other piston, the secondary piston, begins to move as well. When this piston moves past this port, it'll begin to go out this port. The reason for the two separate chambers of the master cylinder is so that if you were to lose pressure in one half of the system, you would still have some braking force to allow you to stop the vehicle. These chambers are not connected hydraulically. They are two separate circuits in the hydraulic system.
So now we're going to go over the compensating and replenishing ports. The smaller port on the farther outside here is the compensating port. Whenever this primary seal moves up, it cuts off the compensating port, building pressure up in this chamber. The replenishing port helps to refill the master cylinder as it comes back out.
Prior to 1967, it was not required to have two chambers in your master cylinder. Most master cylinders prior to that were this style. You can see here, there's a single chamber. And if we were to cut this away, there would only be one piston. This leads to only one line that goes to the entire braking system. If this line or any line in the vehicle's braking system were to break, you would lose all of your braking force from the brake pedal. That would require the use of an emergency brake system.
Since this vehicle is a post-67 vehicle, we can see that it has two chambers. You can tell it has two chambers considering it has two lines here. One of these lines leads to the rear wheels, one of them leads to the front wheels. It is not a diagonal split, so if you lose pressure in one of these systems, the entire master cylinder does not function.
Here we have an example of a master cylinder installed on a more modern vehicle. You can see there are two lines coming out of it, meaning it is a dual chamber master cylinder, and this one has a booster. The point of the booster is to increase the driver's ability to apply force onto the primary piston. It does this by, in this example, a vacuum difference, a pressure difference inside of here. When the driver applies the pedal, there will be vacuum on one side of the diaphragm and atmospheric pressure on the other. The difference in pressure will assist the driver in pushing on the primary piston of the master cylinder, increasing their braking force without increasing the pedal force. In this vehicle, we have a propulsion system that does not create vacuum. Now obviously, this is not the stock drivetrain. However, the braking system transferred over well for this swap. This vehicle has a hydro boost system. Hydro boost was initially invented for vehicles that were operating with a low vacuum, such as a diesel engine. The point of a hydro boost is to produce boost without the use of vacuum. They oftentimes use the power steering system as their source of pressure. You have an inlet hose and an outlet hose, return hose, to the power steering system. And the pressure hose brings pressure in, and when the brake pedal is pushed, it moves a valve that will apply pressure to the master cylinder.